Okay, I'm going to record. Awesome. All right, so it's 3 after. Let's just roll. we have lots of stuff to go through. So for those of that don't know me, my name is Kerry Bruce. I am a drug pusher, so, for lack of a better explanation. My drug of choice is the Raspberry Pi. Hands-on learning in the IT environment. I do teach computer information systems at Central New Mexico Community College in Albuquerque, New Mexico. My primary focus is on system admin, so cloud computing, servers. I teach the IoT courses here. I teach the robotics courses. We have a competitive robotics team that we take to England every year that they have an in-person events. The last 2 events have been online. I also teach the CompTIA battery of A+, Net+, Security+, those kind of things. My dean and my associate dean are super kind to me and let me play with these kind of things all the time. In fact, we've actually built out a lab specifically for robotics, IoT, PC hardware, building, printing, 3D printing, those kind of things. By knowing me, you will probably end up spending money, hopefully, for good reasons, right? So to expand your knowledge or to enhance your students' experiences by introducing them to hands-on kind of activities, things that will stretch their imagination, their creativity. If you've read my bio at all, my first computer was a Commodore VIC-20. So, and if you're familiar with, the old, the Commodores, the TIs, the TRS-80s, those kind of computers, in order to make those work, you had to learn how the computer worked. And using that mindset, right, that mindset of how I learned, like, I don't want to take people back to learning on a Commodore VIC-20. That's not what I'm hoping to do here. The idea of the Raspberry Pi is really similar to the idea of those original personal computers, where you have to learn how the computer works and how it functions in order to do what you want to do with it. And then once you learn that, you're opened up to this really cool world of computing that you don't get if you have a laptop, right, sitting on your desk, or if you have a desktop computer, because those are more, they're self-contained and they're not. You don't get unless you're, when you're programming, right, you can program things on the, game development, things like that from a creativity standpoint. But, most of my students are sysadmin students. Like, let's learn how to maintain a computer, connect a computer, build the networks, run servers and things like that. And I really need them to start thinking outside of the box. So putting a Raspberry Pi in front of them and giving them an end goal and a pile of parts allows them to think creativity. I can't even say the word, right? Creatively. That's what I'm trying to get to. So that's kind of the focus, right? And for this class, this is probably about the 3rd time we've done a class similar to this particular class. And I know some of you have been in previous workshops with me. So some of the stuff will be repeated. What we're going to try to do, though, is to introduce a whole bunch of new things. I think it's constantly changing. The ecosystem around the Raspberry Pi is constantly changing. So there's always new things to kind of dig into. I know from the responses that I got from the questions that I sent out last week, a lot of folks are looking for what kind of projects can I bring into the classroom? And that's a lot of what we're going to try to do over the next couple of days. Okay. So there we are. If you like PowerPoints and you like fixed agendas, this is probably going to be a rough class for you. I don't ever run these classes that way. In fact, I don't run most of my classes that way any longer. I do have an agenda. Like, I can prove that I have an agenda. So right, that's about as agenda as I get. So just to be aware, right? So we've got things we're going to do this morning. We're going to install a Raspberry Pi this afternoon. I got four blocks of time for Raspberry Pi projects. And I left them blank because I want to see what it is. Like, I want to gear those towards what we're doing, you know, what you do, right? And we'll find appropriate projects for that. And then we'll get into the Pico, and then we'll wrap up on Friday. So we do have an agenda, have a plan. This is what we're doing today, right? So more things written down than I think we'll ever get a chance to get to. But I want you to know that, because I think I kind of feel like I come across like I don't know what I'm, you know, we're just going to go random, and no, I have an idea what we want to do, and I want to really kind of gear towards you and your interests, and I'm comfortable enough with what I've been doing with this, with the Raspberry Pi and with these workshops, that we can spin that on a dime, and we can go whichever direction we need to head. I will tell you, a lot of times if we get into topics that I'm not familiar with, I'm going to let you know up front. We're still going to plow through them, because I'm also comfortable with that. I'm not afraid to make mistakes in front of my students or in front of you as other instructors. So yeah, that's just how we're gonna roll. All right. So I hope that works for you. I hope that you are ready to have some fun and kind of learn a bunch of new things this week. It's gonna be a lot of fun. So let's take a look at, let me share my screen. Let me probably get rid of my email that's in the background here before I share my screen. That'd be good. So share the screen. All right, so you should see my desktop at this point. I got to move the video over and the chat over here so I can see what's going on. And then I want to bring over, so we'll bring over this page. And then I also want to point out, so earlier today, I added everybody to Miro, M-I-R-O. I think I saw about half of you have already logged in, and I haven't looked lately to see if anybody else is logged in. So that's a tool. I want to try to use that tool to gather ideas and thoughts, and when we get there, I'll show you that tool. But the idea of that is just to have like, and it's basically Miro, if you're not familiar with this, kind of like it's an electronic whiteboard, and they have templates and things that you can use. So I've got a couple out there, a mind map, which I think will help us as a group kind of formulate where things fit and how to use the Raspberry Pi in different scenarios. And then there's also like a parking lot. So as things come up, right, I want to record them, you know, someplace, right? And that's a place where you could actually record items on your own. And we can then kind of organize where we're going to head with things, right? So we'll probably use it as a brainstorming platform as well, just to get some ideas as to what people are interested in. And we'll use it from there. So that's the first thing. So and I sent it to the email that was listed as your registration email. So if you haven't seen it or you need that, you can try and figure out the best way to do that. Probably ping me. You can send me an email, Carrie@myitinstructor.com. Go ahead and send that, send me an email to there if you didn't get that, and we can maybe at the first break, we will adjust and see if we can get you on. All right. The second thing is I created a Google Drive for this, and we'll throw a bunch of more documents in here as we go through the week. But I did also start a shared Google document. So you're allowed, I want everybody to jump in on this one, right? So this document is meant to be a collaborative space, right? I want you to share web links. So if you are already using the Raspberry Pi, or if you know of a really cool project, or resources that people could use for the Raspberry Pi or the Raspberry Pi Pico, either one of those, then please add it here, add a little, tidbit about what it is. This is let's say, Katie has one that we've been looking at earlier this week, like the weather station using a Pico, right? So, or something like that. Or this is an online class for the Raspberry Pi that I took. It was really good, or something along those lines, and you share the links with us. The idea of this is because I think one of the main reasons most folks are taking this course is if you're already familiar with the Raspberry Pi, right, is obviously getting more resources to teach the Raspberry Pi. And if you're not familiar with Raspberry Pi, that's like the best site ever. So buy my life up. If you're not familiar, then obviously we want to give you this humongous amount of resources that when we leave here, you can come back. I guarantee you will have at least a summer's worth of material from when you leave this class, as far as material that you could access to increase your knowledge, or material that you can use to then to create projects that work in your classroom, things like that. And in fact, a lot of the projects that we'll show you, you can just go to the website and run them right from the website. That's what those two are for. So those two items are there for you for us to collaborate as a group, and to share and come out of here with lots of really good ideas. Okay, lots of really good ideas is a good thing. All right, cool. So let's go here. So this is actually, if you go to myitinstructor.com, the WOTC, just I have a WOTC thing with kind of all the different things I've done already. But if you just click on the WOTC header, it'll take you to this page here. My website's kind of like what goes on in my head, right? I start to collect data, and I have all these things, and then they start, there's all kinds of cross pollination going on. But it's not organized whatsoever. It's like, this is kind of in the wrong place, but I'm going to copy that over to our document over here. We'll put this one in there. Under the heading, why teach CIS topics with the Raspberry Pi. Okay. So I did a presentation a while back, right? The winter conference, a little bit, year and a half ago or so, talking about, using the Raspberry Pi in CIS, right? So one of my hopes eventually is that I really think, I think if you work at a community college, you probably understand the difficulty of making something like this happen. But the idea is I would love to have, a brand new CIS student, right? Day one, right? Signed up for CIS students, you're registered as a CIS student, you're working on a CIS degree, right? Then we have a kit, a Raspberry Pi kit that you would purchase on day one, right? And in coordination with all of the instructors that teach all of these classes, we would integrate a Raspberry Pi project, right? At least one project in each and every class, okay? I have an IoT class where 75% of all the projects are on the Raspberry Pi. I teach server classes where we haven't done it officially yet, but we're working on putting together some Raspberry Pi based projects in the server classes. There's, we have a cloud computing class, so we could easily create a project where we're going to connect the Raspberry Pi to a cloud provider, and to gather some data or whatever the case may be. But the idea is that if you have this Raspberry Pi, it can be integrated in every single class in a CIS program in some way or another. So that's kind of the hope and the mindset behind behind these workshops is this idea that for a community college student, if I can get you, right now they're ridiculously expensive because of the lack of supplies. However, right, so in a normal day, a normal world, right, $100 to $300, right? So it's $100 to buy the basic kit, and then by the time they get done, like I say, I'm a drug pusher, you're going to buy, you'll buy a camera, and you'll buy a board here, or a hat here, or some other cabling, some other, buy some other parts and pieces. But a $300 expense over the time that you're in a community college program is a pretty minor expense when you consider, I've seen some of our textbooks cost $220 for a semester, which is silly, but a lot of times that's what they cost. So the idea is, like, for the small investments in the gear and the coordinated effort to have you use that gear in, say, a half a dozen to a dozen classes throughout your time in school, allows us to give you some hands-on creative opportunities to use this computer to learn topics within your course. So that's kind of the idea behind this whole deal. So why, the very first reason I kind of talked about already is this cost, right? So the low cost. So even with the current kits being so expensive, I mean, they're in the $250 to $280 range right now. That's less than what it would cost you to get a decent laptop to do your homework on. And the laptop is then limited to being, the laptop, right? I can't turn the laptop into a weather station. You can't turn the laptop into a streaming device that easily. I could, but it's not easily, and then it wouldn't be usable for other things. Whereas the Raspberry Pi, I could turn it into a streaming device, and then I could turn it off and unplug in a different SD card and use it for something else. So I think from a cost perspective, right, a lot of what I do here is to keep our students' costs down, right? So, add to the fact that, first of all, community college students, right, stereotypically don't have a lot of money, and then I teach at a minority serving university in a state where the poverty level is pretty high. So we have this combined multiple factors where money is usually an issue. Okay. So costs, right? So, keeping our costs down, but allowing us to get, to use the device to learn a ton of really interesting things. Okay. Flexibility, right? So the thing about the Raspberry Pi is that the Raspberry Pi is not only is it a desktop computer, right? So I mentioned that earlier. It's a single board computer, meaning it has processor, memory, and video built into the processor. I just saw somebody's not seeing this particular screen. Am I not sharing this screen? I'm going to double check this.
No, you're sharing the screen. I've got it.
Right. Carrie, no, I was talking about trying to bring it up on another machine, and I'm not seeing this one at the downlink on your page from WASTAG.
Oh, okay. So so you this page, you're trying to bring this up on a do you try to bring this up on a different browser? Is that what I'm trying to understand?
I'm trying to bring it up on another machine.
Okay.
Because I've got 3 screens running right now.
Okay. So then, yeah, so I don't know. If you go to my IT instructor, the main page is this one. And then if you just click on the WotC, it's actually that page. There's a bunch, it's none of these other ones underneath. Maybe not. All right. Flexibility. So, right, it is a desktop computer. You can run, right, it runs a Linux operating system. Raspberry Pi makes a Linux operating system. And then I'm going to show you a website in a little while where you can see that there's probably 30 or 40 other operating systems that can be installed on the Raspberry Pi. So super flexible from the standpoint of running it as a desktop computer, running a multitude of operating systems. And then the Raspberry Pi has Gpio pins. Let's do this real quick so you know what I'm talking about, right? For those who, right, this is a Raspberry Pi, right? So Raspberry Pi 4, you can tell from the two micro HDMI adapters there, but this is what I'm talking about from a GPIO standpoint, general purpose input output pins. So these are, I can run 5 volts, actually run 5 volts in to run the power to run the unit, but we can run 3.3 volts out to run pretty much any digital device, right? So like, not device, but like LEDs, buzzers, buttons, things like that. We can connect to this. There's also ways to connect to other boards, other things called hats. We'll show you those a little bit later, but that makes this super flexible. So I can add LED panels to this. I can add, there's actually a PoE hat that you can plug into the top of this and run, power this over Ethernet. There's lots of really cool things. I'll show you a bunch of those a little bit later today. But this here allows us to be super flexible. Not only is this device a computer, like that you can run a desktop operating system, and in this current form, the current Pi 4, the Pi 4 is easily, I mean, it can run as a desktop computer pretty easily and handle quite a bit of stuff. There's actually an 8 gig version that can run a 64-bit operating system. So you can actually run, show them the difference between 32 and 64 bit operating systems, a lot of things like that. Okay. The power and the size, right? So it's powerful enough to be a desktop computer, but it's the size of a credit card. So, right, it can fit in a small container. In fact, like I use, I have these kind of little plastic containers. You can see I've got like 4 or 5 Raspberry Pis in here. And then you can, buy a case, right, where the computer can stick in the case, right? So then that can easily be thrown into a, into a backpack of some sort, right? So students can carry that around without messing up the electronics, right? So there's lots of options as far as portability when it's concerned. So that's another reason why I think it's an interesting thing that you can use, right? So we don't have to carry around massive laptops or anything like that to make that work. Okay. The fourth reason why I like using the Raspberry Pi is the community around the Raspberry Pi. And what I mean by the community around the Raspberry Pi, like if you're trying to do something using the Raspberry Pi, for example, like, VPN router, right? I can type into Google or type into any search engine, Raspberry Pi VPN router, and you will get, I know for VPN router, you probably get 30 or 40 web pages that have how to set up a VPN router on a Raspberry Pi, right? So then at that point, around the Raspberry Pi, the community around the Raspberry Pi is really similar to the community that's around the Arduino, where lots of people have done lots of things and they all have a tendency to share what they've done, right? And so finding examples, finding fully functional projects that you can duplicate to teach topics is pretty, I'm not going to say it's easy, but it's readily available, right? So a little bit of effort, you can make that happen. You will constantly see in the news, like, the new Raspberry Pi killer, right? So the Orange Pi or the PC Duino or whatever. Like there's always new boards like Dragon boards and things like that coming out. Yeah, and there's lots of them out there, and they all have a place. However, what you will find is they tend to lack community, so you're kind of on your own. Or then a lot of those, they're Raspberry Pi killers, but they cost twice as much as a Raspberry Pi. So, and they don't have the community around them. So be careful with that. And I'm not saying the Raspberry Pi is the only way to go. I'm just saying from the standpoint of the built-in community, from, they've been, Raspberry Pi just turned 10 years old. So they've been developing their software and their boards and their gear and their equipment and their components for the last, they've had a 10-year head start on any of these other folks that are bringing new boards to the table. So just to be aware of that, right? So community. And then number 5, right? Tactile learning, right? So I know when I was starting in computing, right, everything was tactile, right? Because my first storage device was a tape cassette player. so there was, right, it's completely physical, right? You have to put the tape in and do all, hit the play, you got to do all the things, right? Whereas a computer nowadays, right? So if you buy, I got my wife a new laptop, and it literally, you pop the box open and you open the lid and it just goes, right? You plug it in and it just goes, and you follow a couple of prompts on the screen and you're done. If you buy a PC nowadays, right? Normally there's this big piece of paper that says, plug the purple cable here, the green cable here, the blue cable here, power cable goes here, press this button, and then up and running, right? There's not a whole lot of tactile about that, right? And then if you are teaching using curriculum for, like, say, test out, or say Cengage, which we use a lot of Cengage, or any of, Send, there's a bunch of them out here, but they all have a bunch of online labs, right? So then, students are in a web browser and they start a lab, and it pops a screen on the computer, on the monitor, and they go through the lab. And if they mess up the lab, they just wipe it out and start over. There's really no consequences. There's no, right? There's, when you plug in memory and test out, like you're just moving something on the screen. And you're not actually physically pushing it into the board and hearing the clicks and feeling the resistance from the motherboard and that kind of thing. So I know I've always been a big fan of this tactile learning. Like in networking, you plugging in a cable, right? And you hear the click, you see the lights, right? And you have to map to another, and you click and you see the lights, right? That process physically is a lot different than if you did it on a lab where you just plug into 23 and plug in over here, right? For anybody who's ever spent any time in a data center, right? Finding the right switch and plugging in at the right port and plugging in the right place on the router or the right place on the computer, right? There's a whole lot more to it than what you would normally get in, say, an online environment. So seeing those things, I really wanted to bring back that tactile learning, the physically having something on your desk and physically connecting it, or IoT where you've got to get the wires right to get an LED to function properly, right? And you have to learn a little bit. You don't have to learn a lot about how electricity flows, but you got to understand that LEDs, right, positive and negative, it has to go the right way. The electricity has to flow the right direction for that light to work, those kind of things. So I really think that's important, okay? And then finally, right, and I'm hoping that you'll see that this week. I mean, I think raspberries are just fun to play with. I mean, and when you play with them, right, a lot of my students, they start to, I'm going to build, like, a Tor access point or a captive portal or a Wi-Fi access point out of a Raspberry Pi. They start to find fun things that they're interested in, that they want to do with their Raspberry Pis. Okay. And then at that point, right, the students become, self-learners, right? They self-directed, right? They're directing what it is they want to learn. My goal is to get them hooked, right? Which is, right, goes back to the drug pusher analogy, right? I just want you to try this. That's all I want you to do, just try this, right? And the folks that try it and like it, right, those are the folks that are gonna, I believe, that are gonna be, I think they're gonna do pretty good in the field of IT, right? Most of the better technicians that I've known, we're always kind of playing around and doing things, beyond the requirements, right? So, and that's my hope with the Raspberry Pi, is to set one of these in front of a student. And if you've ever taught an IoT class, getting the LED to light the first time, that's like magic, right? It's a big deal for the student, right? The first time they ever try that. Okay, so that kind of gives you a kind of a sense of where I'm coming from as far as why the Raspberry Pi, and and I've used it exclusively, teaching it as an IoT type of a class, or in a I want to say hackerspace environment, but in a computer club environment with my students all the way back to 2000, or probably about the time I started teaching, about 2012, 2013, that time frame. So I've been using those, in those environments, either in the classroom or outside of the classroom, but in a computer club type of environment, programming, physical computing, and then kind of migrated into robotics from there. Okay. And on this page that we have here, this is, right, I've left this page up there, but there's a ton of resources here, right? So, to use the Raspberry Pi in networking, right? Here's a whole bunch of examples of things that you can do with the Raspberry Pi in networking. And then if you're programming, right, there's any language that you can run, not all, but most any language there's an IDE, and use the examples out there on how to use the Raspberry Pi for any of those kind of things. Cybersecurity, we're gonna play with cybersecurity in 2 weeks, right? So 2 weeks from now, we'll kind of crack open some of these and play with those. Cloud computing, right? So lots of really cool things with cloud computing. You can actually set the Raspberry Pi up to be a cloud service, using own cloud, or this is one cloud now. I think it's own cloud. I think is what I've used it for. But and you can also connect. You can connect Raspberry Pis to any of the major platforms, AWS, Azure, and you can collect data and have that pushed out onto the web. So there's lots of really cool web things there that you can do with it. And then obviously IoT is kind of where most people think when they think Raspberry Pi, they think IoT, physical computing, building internet connected devices. And that's absolutely a part of this puzzle. But I'm hoping throughout this week, you can see that the Raspberry Pi is not all about that. There's all kinds of other things that we can do with the Raspberry Pi. Okay, so I know there's a couple of folks that are web developers, or they teach web development classes. So there are some really cool opportunities to use the Raspberry Pi to build web servers and web pages. So lots of cool stuff there. If you're into computer science, right? So AI and machine learning, there's lots of opportunities there. A lot of my the last 3 years of Pi Wars robotics competitions, we were using machine learning to have the robot make decisions based on colors or shapes that we're seeing. So there's lots of cool stuff there. Parallel computing, I've had a student build a 22 Raspberry Pi, so 88 node or 88 processor supercomputer. We call them supercomputers, right? Parallel computing, but so we've had that done and built in the classroom. And then robotics. There's all kinds of really cool things that you can do with robotics. So this is not an exhaustive list. This is just a list that we left off the last time we did that particular course. But I just want you to kind of start to see all the different crazy things that you can do with this platform. Okay, and that's the hope for this particular course, is for you to come out of here with so many ideas. I don't want to paralyze everybody, but you will leave here with you will not have a lack of things that you can use the Raspberry Pi in the classroom for. All right, awesome. I am going to now turn on the timer so that I'm gonna go 45 because I've already been talking for 30. All right, cool. I hope that, I know it took a long time to get there, but I want you to just, before we get started, kind of understand where this is coming from, right? So then as we move forward, we can modify it or make the class make this workshop, benefit everybody that's here. Okay. I have a ton of things to kind of go over. I want to start with, I'm going to start with 2 web pages, right? So Raspberry Pi, we'll just start with raspberrypi.org, right? And raspberrypi.com. So this split is something relatively new. I think they did it maybe 6-7 months ago. It used to be always raspberrypi.org and everything was there. Now on raspberrypi.org's webpage, this is all about the learning side of things, okay? All about the learning side of things. So from an instructor standpoint, right? If you teach at the elementary level, secondary level, right? So anything from elementary through high school, right? The Raspberry Pi Foundation has tons and tons of resources themselves that they provide for free that come with Creative Commons licensing that allows you to modify their lessons to fit whatever you're doing. And a lot of those can be found here on the raspberrypi.org webpage. Okay. Learn to code online. There's, Raspberry Pi over time has, I want to say purchased, but they basically merged with Code Club and Coder Dojo. Right. So both of those kind of worldwide organizations are all under the Raspberry Pi Foundation umbrella. So if you want to learn how to code, or if students that want to learn how to code, there's lots of really cool examples. What I have found is it's relatively easy to convert the projects from being elementary and primary grades to being community college level type things. So you can add things. There's usually challenges that are added with most of these projects. So basically you turn the challenge into the actual project. And we use the base project to teach them the fundamentals that they need. And then that stretch goal is what we use as the end result of our projects. So I want you to be aware of that. And if you go out, there's actually teacher education. Right, so Teach Computing and Isaac Computer Science. So you will see when we go to those web pages, they're all based on the British education system, right? So the GCSE level, right? So GCSE, in my understanding, is like high school, right? for England. So Isaac Computer Science is kind of designed more at that level, right? And then Teach Computing is more for instructors at the elementary level, right? So all the way up into middle school. But you can pull projects from either one of those and do some really cool things with them. And then I think there are, on the Learn side, if you click on the Explore Our Projects here, you will see that they have a ton, right? So getting started projects. So all of these are just projects, right? That you click on it, right? Setting it up, getting started with camera module, robot antenna, push button stop motion, just tons of good stuff. And what I've liked about these, and we use a couple of these in my current IoT classes, but they explain what's going on, and then you click on what do you need. This is the product that I need. Sometimes if you have to install things, it'll talk about that, right? So it's really explanatory as it goes through a lot of these projects. So highly encourage you to kind of go through those projects and find things that fit with what you want to do. Setting up the Raspberry Pi, I typically walk my students through this, but this is actually, if somebody's on their own or you wanted them to, you didn't have a live class or do this in person, then this would probably be a really good resource, right? To have them jump in there and do this on their own, right? And explains how to do this and how to work through the process. Pretty good stuff. Okay, and that's on the .org, raspberrypi.org website. They just came out with this morning, literally. These all new paths. Is that the one? No, these are different. Let me find that one. So Raspberry, so yeah, so this one, and then I'm trying to think before I go any further, right? I think that we're okay there. I'm going to drag this one over. This is also still Raspberry Pi, right? So raspberrypi.org, courses, learn Python. They just came out with these new, over here on the left, a whole bunch of new kind of courseware. So learn to program with Python, right? So there's an introduction for Python for educators, right? Think like a computer scientist, saving and structuring data, programming with GUIs, object-oriented programming in Python, physical computing, and then socket programming for communication. So there's 5 or 6, 6 or 7 courses here, right? That are all Python related. If you are in an environment where you can use Scratch, right? So the block language, right? This can be younger based usually. I don't use Scratch in my courses. I'm trying to, even the idea of going to the Pico is to kind of stick with, Python from start to finish. But those are, available, right? And I would come in and use these if I was, I go out and do workshops for middle schools quite a bit. So we'll take our lab out to middle school. So maybe one of these would help me in that regard. If you're doing web design and development, right? There's an introduction to web development, right? Learn to build an interactive website using HTML, CSS, and JavaScript. And all the ones that are supported by Google, you can get free access for 3 or 4 weeks. And then I think access is, I want to say maybe $30 a month is normal, like $28 to the platform. But I could easily, I can, in 4 weeks, I can grab out of it what I need. So something to think about. And then cybersecurity, right? So those that are teaching cybersecurity. So there's an introduction to cybersecurity for teachers and introduction to encryption and cryptography. So they've got all these really cool, these are all brand new, these paths are all brand new. And I think they've taken some things that they already had, they've added some new things. There's a whole getting started with the Raspberry Pi, right? So I think we've looked at that one and this one. Or we talked about this one, and then robotics, right? So kind of once they know how to do physical computing, like one of my first things is get them to spin motors and then attach them to cardboard boxes and make a robot out of it. And then I really liked, I looked this one up this morning because I'd never seen this one, but design and prototype embedded computer systems. So this is going to get you, it's going to push more into the designing of a system, like, building a, 3D modeling and building, case for an embedded computer. All right, so this is going to be really kind of that IoT final project level for say my community college course. Some pretty cool stuff there. Electronics and robotics, right? So again, if you want to, you're teaching in a electronics program, or if your program includes electrical engineering, things like that, then there's some things here that you can do with the Raspberry Pi as well. And then I don't want to go through all of them, but I just, again, want to show you that it's the amount of material for you to utilize, right, to learn from, and then replicate in your class. There's an amazing amount, and this is just Raspberry. We haven't even left Raspberry's website yet. We're still on raspberrypi.org. Right, so then I love this, right? So if you're teaching high school, right? Right, so teaching computing in schools, right? So there's all kinds of really fun things that would fit in that realm of things. And then that's pedagogy. And then there's actually like when you're just talking about skills, right? Programming 101, 102, web development, cyber. Okay, so kind of all of them inclusive. And you can see a lot of these are designed, right? I think, all of these projects that I was pointing out earlier, right? They're designed for that high school, middle school, high school level. And I know at the community college level, I think a lot of these are really easy to bump up. I've used probably a dozen different projects right off the Raspberry Pi website as they were. Ignoring the, the silly, the fun. I say silly, but they're actually kind of fun graphics, but they're more, they're designed for kids. So, but you take the graphics away and the content is still a valid way to teach students a particular topic, okay? So right? So raspberrypi.org. I think somebody could add that to our list for me, right? And I copy the HTML over. Or raspberrypi.org. These computing classes, I think these are brand, like they literally got an email this morning. I'm like, oh, how fortuitous. So we can drop that into class today. Tons of really cool stuff that you can use right away, right? So knowledge that you can use to be more comfortable with the Raspberry Pi. And I think a lot of folks are afraid of the Raspberry Pi because they're not comfortable with it. I think once you start to play with it, becoming comfortable is pretty easy. And then it becomes kind of second nature to say, oh, could we use this in class? Could we do this? Could we make this? How could I make this project work to fit the overall scheme or the overall idea of what I want to do with your course? All right. So those are the two raspberrypi.orgs. And then Raspberry Pi, they just came out with raspberrypi.com, and they moved all of their software and hardware components over to this website. So documentation, all the forums, news, like kind of the business end of things over here. Education remained, in the raspberrypi.org, it's focused on education, 100%. That's what it is there for. Okay, so on the screen, there's three different versions or three different things that are three different products that Raspberry Pi puts out. So the Raspberry Pi, which is this computer down here, okay, and then the Pico, which we're going to play with both of those this week, and then this bigger board right here, right? So this bigger board is the compute module I/O board, right? And then these four yellow circles, right? That board right there, it's hard to kind of see in the graphic, but this board right here is called a compute module. And what that is it's a stripped down version of the Raspberry Pi 4. It's designed to be embedded. There's actually connectors on the back of this that you plug into like this I/O board or into, say, like a manufacturing piece of equipment or whatever like that. Or a lot of times the compute modules were used to create digital displays out of TVs, right? So there are TVs that take a plug-in module, and then you plug this module in, and then you have a fully functional wireless, compute module that you can actually interact with on the wireless and create digital display boards and things like that. Okay. Marcelo, I'll answer that question in a minute. This is not what they use. They use a custom Pi 4 that they built specifically for that box. So these are the kind of the core components. What's neat about this is you can get these, it'll be the Raspberry Pi 4 with 8 gigs of RAM, or you can get them up to 32 gigs of RAM, right? So you can do lots of things. And then they also now they've come back, I think they came out with they have a SODIMM version of this too. So the one, it has a SODIMM format, and there's an adapter that you can plug in, and it becomes the compute module or the brains for whatever you just plugged it into. So I really want to try this. I haven't figured out yet. I haven't tried it yet. I really think, especially if you want to take a course that goes more industrial, like an IoT course that goes more industrial, then the compute modules is where you're going to want to focus your effort. So this one interests me from the standpoint of, it seems like, I don't want to say the grown-up version, because I really think the Raspberry Pi is a really robust system, but I think like this is going to be that commercialized, that's a better word for it, commercialized implementation of the Raspberry Pi. Okay. And then those are the three primaries, right? You also have this Raspberry Pi 0, right? So the 02W, so the W indicates that it's a wireless. The 02 is the newer version of the Raspberry Pi 0. This thing is tiny. And when I mean tiny,
would you like,
let me show you what I'm talking about.
Share a screen of one.
This is the Raspberry Pi 0 next to a Raspberry Pi, right? So this has a lot of the same functionality as this, obviously minus Ethernet, right? It also has, it's not a micro, it's like a mini HDMI, right? That you would use. You can buy these boards with or without the pins. This one actually looks like, I'm trying to see if this one is, that one's not. That has joints. I think we're still, yeah, that's a soldered one. I have one, it's kind of wonky because but this is, just another format, right? So, but this format costs like with the pins on it, like it's a $15, normally it's a $15 computer, right? So this is just another format that you can use for delivering, or using the Raspberry Pi. Okay, you can install an operating system on it and plug in a video and use the pins like you would with the Raspberry Pi. The other thing that you can do with this one is you can install a Raspberry Pi operating system on a PC. Okay, so in my lab, we have them dual boot the lab computers. You have your normal CNM Windows installation, and then you have the Raspberry Pi OS as a second bootable OS, right? So if we want to use the Raspberry Pi OS, we have the students reboot the machine, choose the Raspberry Pi OS, and when we're up and running. And then what you could do with this is then connect this with the USB, right? Micro here. I connect this to the PC, and using the desktop OS that Raspberry Pi provides, I can then access these pins, right? So then instead of having, a 35, 45, 55, or 35, 55, or $75 computer, right? Now I have a $15, $20 computer, and then I can plug that into the PC and still do all of the same things, right? So again, another way from a cost perspective to kind of bring the cost down. This one has the camera, right? Which I want to say with the latest OS, they kind of moved away from the camera modules. And there are new libraries. I haven't played with the new libraries. There's new libraries. So I'm hoping that stays, because those we found those to be really useful in class to allow people to do projects. Okay, but so just get an idea of what that's about. Okay, and then the other one's missing. Where'd it go? Let's go to the hardware page. So this right here is what Marcelo was talking about. This is the Raspberry Pi 400 personal computer kit. So this is, if you're familiar with the Commodore 64 and VIC-20, I'm like, oh my gosh, they brought it back. So the computer's in the keyboard. That's essentially what's going on. You just basically plug in video, power, and a mouse, which the mouse comes with the kit. And it's a Raspberry Pi. There's an SD card slot. You can kind of see the SD card sticking out right there. There's an SD card slot in the back. And it becomes, right, the computer. And then I think Vilros makes a bag for it. Actually, you have this nice little zipper bag that you can stick everything. You put the whole thing into a little baggie, and they can kid can throw it in their backpack, and then off they go. Okay. Oh, good. Katie pointed out the Turing board. We're going to talk about the Turing board in a little while. So this is another option, right? And again, we have yet to leave the Raspberry Pi website, right? Right, you got the Raspberry Pi 4, right? Which are here's the kind of and you can see the board. The board is a modified. They built it specifically for this computer. It's not like they took a Raspberry and stuck it in the base and then off you went, right? It has, everything is spread out, right? So it's using, a custom board built specifically for this, but it has the Raspberry Pi 4 brains and memory and all those kind of fun things in it. The one thing that it also even has the Gpio pins, right? Back here in the back. The one thing it's missing is a camera module, right? The camera port, there's no camera port on the Raspberry Pi 400. So if you're going to use cameras with this one, then you are using web cameras, which are doable, but you have to use OpenCV in order to connect to and take pictures and do things with web cameras, which at this point I haven't done yet. I started looking at it last week. I'm like, oh, we need to try to figure that out. So that's coming, because I really, I think we can, students can buy this. If they're going to buy this, then I need to make sure that they have that option to do the camera work that we do, versus say buying a Raspberry Pi and buying a camera module. Okay, so the Raspberry Pi 400 is another way that you could easily, and this is the kit that it comes with, right? So it comes with an OS disk. It has the video adapter, power adapter, and the mouse. It's pretty cool. It's a neat little device. Cool. I'm trying to think of what else on the hardware side we need to cover right this second. I think right now we're okay. This is, again, I think right in here, we start looking in the middle here. Here's, right, so folks that are interested in retro gaming, there's actually, you can buy or print cases that look like, old Nintendos, and you can do RetroPie and plug in, if you have the, I call them MAMEs, right? If you have the actual game emulated games, you can actually, install those and play those games on the Raspberry Pi. This NAS, right? So using a USB connected hard drive, you can turn it into a NAS. So that's a good sysadmin project, right? To create your own network attached storage. And then cluster computing. This is a pretty fancy one. I'm going to point out the one that I can find it. So Katie put this one. This one's in the chat. So this is called the Turing Pi. I think there's maybe 10 days left on the Kickstarter, 8 days left on the Kickstarter. So it's like I want to say maybe a little bit bigger than mini ITX. I don't know what the exact dimensions are. But this is actually a motherboard. I'm looking to see if there's these, but you can see right here, there's 4 slots for us to actually plug in compute modules. So you connect a compute module to these base, I guess that's a base plate, it's like a SODIMM type of deal. And then that plugs in to the motherboard. Also, and if you guys are familiar with these are the Jetsons, NVIDIA Jetsons, which I've seen a lot of projects using, AI robotics projects using the Jetsons, but you can use any combination of compute boards. I thought at some point you could plug in Raspberry Pis as well, to create this, with 4 of them, and you've got gigabit Ethernet out. Okay, so then from my perspective as a sysadmin, I can fire this up. I can have students run Kubernetes. We can do cloud. We can build out miniature clouds. We can use, do some parallel computing. I can add hard drives and build NAS units with this. So totally, I don't know. To me, I got super excited. I went and bought one. So I'm one of the drug pushers that uses my own drugs, which is not a good thing. But I want you guys to be aware of this. This is really cool. TuringPi.com. The Kickstarter's on for the next 5 days or so, but I'm excited to try this. Like, I want to try this and see if we can build, if I can build a small, we can build a Kubernetes device, or even say a cloud platform, right? So with 4 compute modules, if I buy the 32 gig version, that's right, we have 4 Raspberry Pis. So this quad core 64-bit ARM processors. So that's going to be 16 processors, 32 gigs times 4, so 128 gigs of RAM on this board, right? So I could then, and then the board's like 210. I think that was the price. That was the price I paid, but I think it's like normally 250, right? 240, 250. And then the modules that I'm looking at are like, I want to say in the $75 range. So that's another 300. And then the backer plates are 10. So you're looking at maybe $500, right, for the setup. to teach, cloud computing, Kubernetes, on a multiple, massive processor, lots of memory kind of a system. I don't know. I think it's interesting. And again, another item for you guys to think about. Yeah, so it's mini ITX, so it fits in a case. Like you can put those in. Yeah, I'm excited. It's going to be fun. So yeah, so go get yours. But that's like from the hardware perspective, right? So like that's where this one came from, cluster computing. You can cluster computers, you can cluster them without plugging these things. Like you can just take a whole bunch of Raspberry Pis, and there are examples out there, and the level of ease and not is going to be dependent on which project you use and how much skills you have and things like that. I wonder, speaking of parallel computing, right? So if anybody is interested in that, I was able to take my students. Yeah, it's been a while, so I don't even know if they're still doing this project, but so LANO, which is Los Alamos National Labs, they built this bad boy, which has, I think, 750 Raspberry Pis in it. And it fits in a rack. This is just I think it's like an 8U module, a server rack module. But they built, 750 node. This is back when you could buy Raspberry Pis. So, and they use Go, right, as the programming language, and they have these power Ethernet switches, and when you fire it up, it like fires everything up in sequence, and then everything checks in, and they got a dashboard so they know which modules are working and not working. But they built this really cool high performance computing computer. This is beyond what students, well, maybe not beyond what students can do at this point. I think students could do this if you had the resources, but right, they're expensive. To get 750 of them would be a lot. I think Ohio State has built one that's 128 nodes. And CNM, we built 22 nodes. So, but if you have students that are interested in that, or you have classes that were parallel computing, hybrid computing, that kind of idea, you have options to do something like that as well. So, all right, I hope that makes some sense. Trying to get back to the .com. Okay. All right. So the equipment, right? So, and I know there's finding the equipment, first of all, right now is really hard. But from a Raspberry Pi standpoint, right? The Raspberry Pi 4, there are still Raspberry Pi 3B pluses out there. And I think they're still manufacturing the 3B plus as a low cost option. However, none of it's low cost at this point. But the 4s are the current version, right? And then the new Pi 02 and the new compute modules. Okay, and then for industry, I think we've already kind of shown you but you have compute modules, and you can see right here, they also have them in kind of a SODIMM format as well. And so here's the IO board. So these are the kind of things I think, if you wanted to take your IoT right to the next level and make it, where you're teaching students how to deal with manufacturing, right, and using the Raspberry Pis in industrial, right, maybe a bit easier to justify, right, the course being in your curriculum. I know in California you've got to justify, how does this lead to jobs, kind of a thing, and I think all of us have to do that in some way or the other. I'll tell you, on my end of things, like the IoT class is in our curriculum, not specifically to teach physical computing. We just use physical computing to teach troubleshooting, project planning, group work, things, presentations. They have to present their projects, creative out of the box thinking, right? We also teach in that same class, we teach system administration skills, right? Flashing SD cards, right? Making backups, connecting to the network. Right? So we have, it's kind of a combined, right? A lot of those, and I don't want to say soft skills, but those professional skills that employers want, right? We use this class to kind of not force that, but basically it's a really good place to make all those things kind of happen all at once, right? Again, it goes back to that tactile learning from my original list. I think the class for us, the IoT class, is difficult for some students because they really rely on step-by-step instructions that work every time in order for them to think that they're learning. And if you've done that class with me before, you know that I actually leave instructions in there that are broken or don't give them instructions because I want it to be as real as it possibly can be to what they're going to be up against in the real world, right? If you run into a problem that you've never seen before, it's not like you're going to have pre-done instructions that's in your textbook to how to fix that problem. So I want them to start thinking on their own. So that's where we put that, where that class is positioned in our curriculum from that standpoint. But I think there's some really cool, commercial, industrial implementations of Raspberry Pi. So you could easily, if you want to take the IoT component up a notch, right, then you could run here at the industrial level.
Can I just give
Yeah.
a quick thing? When the Kickstarter on the compute modules came out, or right beforehand, I was contacting people because of the lack of the compute modules, and there are getting Raspberry Pis, and some of these, it's virtually very difficult.
Oh, yeah.
So they said that this was their response, was that the industry is getting preferential treatment over consumers, and that would include education. So
Right.
given that it started and we were the ones to promote it, all of a sudden now it's gone heavily commercialized with this industry. And that's why you're seeing this, which I think we all need to kind of voice our opinion about the fact that we are the ones who are promoting and supporting this. So just let you know, that's what's going on behind the scenes.
All right.
So they're making them. It's just we're
Yeah.
not getting them because they are going to these pre-contracted, claiming that their jobs are on the line, their business is on their line. Well, our educational students of our education's online. So it's my 2 cents.
All right. Yeah, I agree. I don't, corporate politics. I don't work at San Diego National Labs any longer because I don't like politics.
You can edit that out, but I
I knew you were going to take this part out. I'm not. No, we're leaving it in. I'm going to make that. I'm going to make that a TikTok. I'm kidding. No, I think, and I agree. I mean, there's always going to be a component, no matter what company is out there. I mean, if somebody's paying money for it, right, and there's a big pile of money, right, because even though in education, like I run, every semester we run probably 60 students through, right? So we're 60 units, right? You add up all of the units, but we're all individuals, right? So we're not buying, 1,000 or 5,000 at once. We're buying 1 or 2 or 3 or 4, 5 or 10, 20 or 30. So I agree. I think this, something beyond our control, but I think it's important to think that if that's the case, then perhaps making sure that when we do have availability and we can teach our students, that perhaps making sure that they understand how they work in industry, because there's a lot of them out there, and they're being used a whole lot more than they ever have been in that environment. All right. Cool. All right. So far, all we really have looked at is we've looked at kind of some learning resources that are available from Raspberry Pi. Okay. We've looked at the hardware that's available from Raspberry Pi. And there's lots of options. And then as we go through the next, 3 or 4 days, we can figure out like what it is, what, you can start to look at or formulate it, what types of devices would work best in your classroom, how you would use them, that kind of thing. So in my classrooms, we started we used Perkins funds to purchase a lab set of Raspberry Pis. And we used those Raspberry Pis as a classroom set for probably going on probably 3 years before we had enough kind of component failure from either misuse or accident or whatever over the course of time to have not enough Raspberry Pis to actually conduct the course. And then what we did at that point is switched over to the students purchasing the gear. And that works well until the spring semester, because that's when things got really they got ridiculously expensive at that point. So I tried to do a combination of those, like you can come and use the machines that we have in the lab, right? Or you need to buy your own components. And half the class bought their own, the other half showed up in class. And part of the agreement was because we only had one class a week in this particular semester, it's like, okay, understand that you can't get everything done in one class. You'll have to come in during open lab time. And not a single one of them did. I think that's not true. I think maybe 3 students. So I had a lot of students that weren't able to complete their work because they just simply didn't want to come in and do the work. So I'm kind of at a crossroads with, do I have my students, spend, god awful amounts of money, right, to buy a Raspberry Pi kit, or do we go back to maybe providing a classroom set, right, for them to use? So I'm still kind of in the middle of that kind of thinking. The one, move that out of the way. I can find the right. Yep. So one of the primary things that I have been working on is I do robotics, and we do Raspberry Pi based robotics. And PyTop, if you're familiar with PyTop, if you've had any of my classes, you're probably familiar with PyTop. But PyTop, they don't even have they don't anymore. So they used to have, and I'll show you a couple examples. They had a laptop. They started out as a laptop, a Raspberry Pi based laptop, and then they built these little all-in-one Raspberry Pi monitor, and you just plug a keyboard and mouse into them. It stood up on your desk. And if you've taken a workshop with me, we probably use those in the workshop. And then they moved to a new laptop, and now they've moved to this right here. So everything from the little teal color up is actually a Raspberry Pi 4. It's encased. The pinouts are up here on top. You can't really touch the electronics. It has battery, right? There's battery built into it. It's got the little display over here. On the other side, it's got all of the regular ports that you would use to connect to the Raspberry. It's got thermal, right? So it's got fans and other things like that, but it's like an expensive version of the Raspberry Pi now, right? So, because I think these units are like $200. I want to say they're about $200 a piece, just for this piece here. But because I have one of these, this is a robotics kit. So down here's a robotics kit, and you can see there's this base plate here, right? And the base plate allows me then to use quick connect adapters to do instead of having to use wiring or jumper wires, things like that. And then on top of that, they came out with this is a touch screen that this unit clicks into the back, and it'll stand up I don't want to say it's more like a surface, right? Where it's not this hinge right here is not solid, so it won't stay like that unless you have a way to prop it up, and you actually prop it up with this And then they have a keyboard that you can connect to it as well. So this combination is like an expensive version of the Raspberry Pi, but what it does do for us is that it prevents what 90% of what was the problem before, which was folks messing with the GPIO pins and burning out things like, physically, if you cross the 5-volt with another pin, right, you can actually burn out the GPIO pins, you can mess up the computer. It also is a computer, and if they're, handling it with their fingers, and there's always ESD issues that you can have problems with. So this was an option as well. And luckily I had funding, and I bought a lab of these. So I have, we actually have enough to do an in-person lab and a mobile lab of robots and desktops with these. But if you're, when you're looking at this, these things are not cheap by any stretch of the imagination, but I think they give you a platform that can be used in a classroom that kind of helps prevent problems. The only thing that I see is, it's hard to see with that picture. Let's look over here. Right here is where the SD card goes, and taking this little cover off is kind of painful. So if you have multiple classes like I do, like the students would have to take the out because they're going to share the computer. So I kind of see us eventually losing most of these little pieces, these covers. It doesn't affect the unit itself, but I don't think that cover will survive, but 2 or 3 semesters at the most, with students constantly changing them in and out. So this is something else to think about, like from like if for having your students do things. Most of them you can get with this electronics kit, right? So now the LEDs, they have these little quick connect wires, right? So I was talking about these quick connect wires. Here's it looks like maybe a joystick or a button actuator. Oh yeah, here you go, the superset. So everything, $300. Is that the superset with the Pi? I think that's going to be the Pi. That's going to be all of these pieces, I believe. So they're not cheap. So that's actually not bad compared to some other things. Let's make sure I'm not mistaken here, because I think I may be. I'm pretty sure the robotics bundle, yeah. So the robotics bundle and the electronic superset is $449. So those prices don't include the monitor or the. And you don't need a monitor. You can plug in. You have to have a USB-C to HDMI cable, but you can plug in. I believe it's HDMI. I don't. We'll have to double check that, but you can plug these into a regular monitor, keyboard, and mouse. So you don't need to have those other components. So that superset, that $279, is going to be with these little. There's a whole kit, and I'll later on today I'll show you that kit. I have the kit. I can show you what it looks like. I just want you to be aware of it. Here's the kit over here. And then you just click the base plate onto the bottom of the Raspberry Pi 4, and then you can connect using the quick connect wires, and then you can program like you normally would program. And they've got ultrasonic and sound and buzzers, and I think a temperature gauge and some other things. These also will, there's these little base plates, you can plug them in and they plug into Legos, right? So then you could use the little green flat Lego pieces as your breadboard, right? So you just plug everything onto the breadboard. And so I think there's lots of really cool options that you have when it comes to, deploying a Raspberry Pi. So from a classroom perspective, because I had funding, I went this route so that I can allow my students who don't have the way to buy their own to use one without it, in this, I can put a little case on it in case it gets dropped or bumped or whatever. And I can prevent them from messing with electronics and things like that. So, so that's an idea of how to use the equipment, right? So how to push that equipment out there. All right. Okay. So then my timer did go off. So that's awesome. So let's take a break. I wanted to make sure that because a lot of questions early on revolve around equipment. Like, I know it's been hard to find equipment. Where do you get equipment? So once we get back from break, I want to finish that conversation. And then I want to talk about projects and things that are, where do we want to go with the next 2 days of projects. And then we'll get into actually setting up the Raspberry Pi. All right. So that's going to be our goal for the day. Making sure you are at least aware of the equipment, how I use it, how you could use it. And then we'll discuss what kind of projects we want to work on. And then we will work on doing an installation from scratch of a Raspberry Pi so that we have the equipment ready to go for the morning. All right. So let's take, let's say 15-minute break. Let's put a timer up real fast with one of my 52 browser windows. 15-minute timer. All right, I'll see you in 15. All right. Trying to make sure we had all those web pages on our document there. There's a ton of them. So, and I apologize. I was thinking, I was like, man, there's just a lot of material to cover early on. So it's like, it's going to feel overwhelming. But I think by having it in that page, you can kind of go back and look. And then at any point after the class, in the evenings, 2 months from now, 6 months from now, whatever the case may be, if you have questions on any of this stuff, please hit me up via email, and I will be glad to help out. So, did have somebody ask if we were recording the break, and the answer is yes, because I'll forget to turn on the recording when we get back. So it's just one of those things. I know I'll do it. I've done it before. I was like, oh, I'm gonna stop, and then 30 minutes into the next one, and I just completely forgot about it. So okay, let's keep on trucking. Put the timer on again, which actually the timer, yeah, we'll do. Let's do 45 minutes, and we'll go to maybe a smaller break in 45 minutes, and then we'll have another 45, and then it'll be lunchtime, I believe. So let's take a look at, right. So again, I know there's a lot of information, and we are going to get to the doing part, but I really feel like we need to have this. You need to see kind of what's out there, so that then as you're working through these labs, you can kind of formulate in your mind kind of how you see it happening for you, or in your classroom, or whatever the case may be. So, so I want to, and I brought this up, so you can see across the top here. It's the Raspberry Pi is available in lots of places, and I tried to focus on, for the most part, not completely, but focus on kind of US-based suppliers, because I know a lot of schools, if you're going to purchase, you need to have, it needs to be a US-based kind of thing, or you have to go through all kinds of funky paperwork. And we've bought stuff from British suppliers, but it took an extra month or so, and it's already purchasing through a community college is always terrible as it is. So. So Sparkfun, let's start with Sparkfun. That is, right, so that's the kits. If you were to do the IoT Connecting Things course and look at the Cisco kits that they recommend, it's all Sparkfun kit, right? It's usually, I think they want you to do like maybe one of these starter kits for the Raspberry Pi, and then an Arduino starter kit. This one, I have a price on it. I'm like, they don't have these in stock. But these kits, what I like about Sparkfun is the quality of the components in the kit are really good, right? They're really good. And I have never had, problems with Sparkfun in their kits. So I if they have in stock, it's one of those places that you can order from. One of the neat things about their starter kit is it has this FTDI right here, this little device or little breakout board. And what's cool about that is that allows you to actually connect to the Raspberry Pi, to the serial port on the Raspberry Pi, right? So it's built into the kit. Otherwise, there's a cable that you can buy. And if you've done the IoT security course with me, we did that project. I really like that project. But that's one of the neat things that this particular kit has. It looks like they've added pretty substantial, that looks like a top to the case, but it looks like maybe even a heatsink kind of a deal. But these kind of kits are nice. They have the SD card and buttons and LEDs and some other stuff in them, right? So Sparkfun, right? So if you're going to be kind of sourcing supplies, Sparkfun is a really good place to get supplies. they tend to be maybe 10 to 20% more expensive. Because like, you know, if you buy from Vilros or like Elegoo or whatever, you know, any of those Amazon type of sellers, I think the components are not as nice, right? So that's going to be the difference between the two. I like the buttons, you know, that come here. I like the bigger buttons, not the little tiny ones and that kind of thing. So be aware of that. You can also get the 400 kits here as well. And then the one other thing that I thought, or that you should be aware of from Sparkfun, if you're going to do, oh, here's the Raspberry Pi, the laptop that they have. I have one of those. I use that to teach when I'm teaching classes. So I'll actually fire that up this week because I can see the screen and I have a keyboard. So from a teaching perspective, I'm not 100% relied on remote control, remote VNC type of a connection. For the Pi 400, I'm not seeing it right off the bat, but there is, if you go this route, like if you go this Pi 400 route, okay. And I mentioned earlier, right, they got the pins here, right? So super obnoxious to get to the pins. So the only way to do that is there's two ways of doing that. You could get a ribbon. You could buy the ribbon cable and the T-bar, right? So the ribbon cable plugs into the computer and you plug it in here, and then this plugs into a breadboard, and then all your pin outs are there, okay? I don't know. I've always found that to be kind of clunky. So I never really have done it that way. What I have done, I don't know why. Let me see if we just search Pi 400, if it'll come up. Oh, this is what I like right here. For $5.50, you plug in, this plugs in, and then your pins are right there, right? So you put these little legs on the bottom so that it sits nice.
That's my issue with this one.
Yeah, sits nice with the table.
It's a little. It's not right. That's
And
okay.
then you have access to the pins, right? Sticking right off the back of the computer. Here's what it looks like right there, right? So I love this, right? So that's, if you're gonna buy this kit, this $5.50 right there is well worth the money. So I have one of those in my kit for this particular device. So that's, again, Sparkfun, that's one of your options. I'm gonna put that in our.
There's a benefit, another benefit of that hat, Carrie.
Uh-huh.
It has the quick connect system, the new one. So it means you can connect to the connecting things. There are at least, 20 or 30 different connectors that you don't need a breadboard. And you can connect up to 7 on each chain. So it's actually pretty cool. It's cheap for $5.
That's really good. Yeah. So I didn't see that right here, right? Are these quick connect modules, right? And if you start buying quick connect components instead of individual LEDs, you buy a quick connect LED and you just have a little cable, a pre-done cable for you. So that's a really good idea, right? That's a really good way to.
Yeah, because you can bypass the breadboard and the wires and all of that if you're just doing demonstrations on how it works.
Yeah. So that's a great addition. I didn't even realize that. That's awesome. That would be the dollar difference because it used to be $4.50. Okay, so Sparkfun, I put it on our list. The next one, let's stick with this, right? So we're trying to kind of stick US based, right? So you can buy Raspberry Pi stuff from this company called PiShop.us. We purchased, my school was purchased from here. Again, what they have in stock and what they don't have in stock, I don't know, but I know that you can get quite a bit of supplies from here, right? So the cameras, and you can get, they have some hats. Those are nano based hats, but let's see if they have, right, so they do have some of the Pi Moroni gear here as well. So you can buy some of this stuff. You got ESP82 modules, right? So this is the Pico. This is the Wi-Fi module that you can connect to your Pico. Okay, all kinds of cool things that you can get. So again, I think a lot of this is going to be exploration. What kind of project are you wanting to build? But I just want you to be aware of the locations, right? Because a lot of times, we'll go out to Amazon because that's the easiest thing to think about. And there'll be a real limited number of things there, or an overwhelming amount of, I just can't get through the minutia of all of that. So Pi Shop US, we've bought from there. They've done really well for us. In fact, that's when we bought a set of 10 Raspberry Pi 4s early on with PoE hats and everything. So that's a really good shop to go to. And then Vilros. So I use Vilros a lot, right? So this is a good place for students to get inexpensive kits, right? So the kits are less expensive. Like I said, the components are not as nice, but they tend to have kits in stock quickly, right? So like this is I think this is the kit I purchased for myself, but then the one I was hoping people would get is there's one that has all the components to do everything out of the lab, out of the book that we're going to use. So they got Pico kits, they got Raspberry Pi kits. You can buy individual components. I've had students buy like DC motors here in order to be able to do raspberries or do robots with the Arduino, that kind of thing. Okay, and they've got the whole range. And again, it depends on stock, right? So what's in stock. A lot of times you'll find Vilros on Amazon as well. And then I believe most of the time, like if we go and let's just grab this one real fast, they have free shipping. Depends on maybe what sale's going on. But most of the time you can find a way to get shipping for free from Vilros. So Vilros would be another option. I'm going to copy that one over to the list of things, right? All right, so Vilros. Then Chicago Electronics Distributor, I have not used them. However, they do have a ton of gear. And again, if you're looking to buy components and pieces, they may have stock, they may not have stock. They obviously have lots of good gear here. Or maybe you find it here and then go see if you can find it on Amazon as well. So that's always an option as well. But they have a lot of cool things. So, and I kind of scrolling through things, but like for those that are pretty new to the Raspberry Pi, right? I'm trying to find, this is a PoE hat, right? So you can actually fire up the new Raspberry Pi 4s on a PoE network. So if you wanted to teach PoE and PoE networking, I think this hat, I'm gonna say it's maybe, how much were they? Maybe $25 or something like that. So it's a $25 add-on, but then you can just add that to any Raspberry Pi and show students how that works. So it's a pretty inexpensive way to do that. They've got the camera modules. They've got a fan shim. So this is it just sits on the pins there. You don't have to actually put anything on top of it, but it'll run a fan to keep your unit cool. I like this little device. I have one of these, but this is a USB-C power switch, right? So you just plug in this into the power, and you plug this into the Raspberry, and you can turn it on and off instead of unplugging, constantly unplugging. So again, another way to minimize touching the gear, to minimize ESD and those kind of things. The Sense Hat, which is a really fun device. And when I say hat, hardware attachment on top, for those that are new to the Raspberry Pi world. So, and we'll see when we get over to Pi Moroni and Pi Hut, the wide range of hats that you can get nowadays. But this is one that has this 8x8 LED matrix, right? And then on top of that, there's a gyroscope, accelerometer, magnometer, barometer, temperature, humidity, and a joystick, right? And you can pull data from all of those, put data into CSV files. You can put it online. You can use the joystick to play games. You can use the joystick to trigger. You can use the accelerometer so you can shake the Raspberry Pi and have it trigger an event. I used to use these in my classroom all the time until, again, obviously, I think over time, plugging them in and out and having multiple students every semester mess with them, our pile kept dwindling, so we've stopped using this particular unit. But I really like this from the standpoint that you can do a lot of really cool things with it. I'd use this LED matrix to do an outreach program. So I would go to like college fairs and we'd set up the pies with these on it. And the students would actually be able to design an animation in like 5 minutes and then run the animation on the LEDs. So really cool stuff. And I want, again, just kind of sharing to kind of, have you, right, your idea generation, like what could I do with this? How could I make this happen? And then the new camera module, which is crazy. This is the new, is this the high? Yeah, so we got a high quality camera. It actually comes where you actually have to buy lenses, right? Like, holy cow, they went from this like inexpensive camera to these crazy, you have to buy, lenses and all kinds of crazy stuff. So you have, the camera is it's really awesome, but it's expensive, right? So I give, if I'm buying it for myself, I'm like, I'm okay with $50, but I don't want my students to have to buy $50 cameras, right? So what I have my students do when they need to buy a camera, and I have them buy a camera if they're in my class, because we always can use the camera. I have them come out to Amazon, and I have them buy, this is the version 1, and there's a version 2 of this, so the newer one, right? They can get away with either one, but this RGCam, that brand, they're the original manufacturer for the equipment, right? So this is actually a Raspberry Pi $25 camera that they're selling for $20 or $10. And then they have a version 2, that's not them. There's another one, Arduino, I'm looking for the RGCam. I should have just looked up RGCam. So I have them buy it that way, right? So RGCam version 2. The wrong button. Me and my computer are not getting along right this second. Oh, that's what happened. So the version 2 is the newer one. It's an 8 megapixel version. And that one has the lens on it. You don't need the one with the lens. It's a 5 megapixel. It looks like they don't have the version 2. I'm missing the version 2. But RGCam, just their basic camera module. So, instead of having students spend $20, $25, $30, $50 on a camera, have them go out to Amazon and buy those RGCams. They work just as well, right? And then if they have a web camera, like a USB web camera, there are ways of doing that as well. Okay, it just requires separate. I like to have them buy the Pi camera so that my when I give them instructions, everybody's following the same instructions. If they get a web camera, then they have to do OpenCV and some other things. But this is, again, just showing you all the different things that you can add, right? And I don't think you should just go buy, stuff willy-nilly. I'm using all these really, old time words. Sorry about that. You should just don't go buy it, just because, right? I really think you buy them specifically for a project or for a series of projects that you could do, use these items for. So, but Chicago Electronics is another one of those places where you can go. It's one of the official providers of equipment. And there's also Micro Center. So if you live near a Micro Center, you can go to Micro Center and buy the Raspberry Pis there in person. I don't know if they have them in stock or not. I know there's a Micro Center in Orange County. I think it's the only one in California that I know about. There's one in Denver, Houston, St. Louis. Those are the ones that I go to. So anytime I'm in any of those towns, I'm actually going to the Micro Center. In fact, if we ever do this again in Mountain Grove, we will actually go for one of the lunch periods. I think, Mike, you've been with me. One of those excursions. But we skipped lunch one day and went to Micro Center, and we all came back late. So, but I love Micro Center. I think when I retire, I'm going to work at Micro Center because I can just continue talking about computers. Not on a part-time basis and not have to do class prep. I could just talk. So that'd be work. But Micro Center is another good option. they don't sell the Raspberry Pis online. Like you have to go to the actual store. But be aware of that one. And then CanaKit, if you've heard of CanaKit, they usually have really nice kits. They're usually a tad bit more expensive than others. But they have accessories and, and they do all the same thing the other places do, but they've been around almost from the beginning. So something to think about. This does bring up, and I don't know if you guys, we didn't talk about this one, but the Pi 3 A+ kit, right? So this computer here is great if you don't want internet connectivity, because it doesn't come with an Ethernet cable. I guess you could use USB and plug an Ethernet in that way. But they're a little less expensive. They're also about 2/3 of the size of this board. The Pi 3, you're going to lose a little bit of power. But they're also, it's an alternative. It used to be like the $25 option. Instead of buying a $35 Raspberry Pi, you would buy the A+ kits, and then it came out with the Zeros, which were half the size, which had more. They have about the same amount of function of these, but they're just quicker, right? So these are kind of the old version of the Zeros. But just be aware, CanaKit is another really good place to go. Again, I want to, I know I kind of feel like I'm maybe too much, but the more of this stuff you kind of explore, I think the more ideas is generated, and then the more options you have as far as sourcing material, the better. And then OKDo, these are relatively new, and I don't even know if they're US based or not. But they have, again, same kind of thing. I have not done much with OKDo, but I know they have a lot of really cool stuff. They do a lot of microbit stuff, IoT and computing. Again, another website to maybe explore and check it out. What else we got? Oh, so those ones. Oh, Adafruit, right? So if you've done anything IoT, anything Arduino, then you're probably familiar with Adafruit. But Adafruit also sells Raspberry Pi stuff. They also have a lot of their own equipment that they've built to do things on the Raspberry Pi. All right, so this is kind of nice, a PWM servo hat. So this is going to give you analog connectivity to your Raspberry Pi. It's pretty inexpensive. So pretty cool stuff there. The base plates that you can get, there's an expansion plate that you can get for that Pi top 4 that I talked about. It includes servo and an H-bridge for motors, driving DC motors. So that's also doable with the Pi tops. So paste, and we have that in the list as well. And then the last 3, is this one? Newark. Oh, so Newark is more of a electronics company, but they also have Raspberry Pi supplies. Again, the more of these that you know about, the better chance you'll be able to find a piece of equipment that you need to be able to pull off a project or supplies for your students or what have you. So I'm going to save that one as well. I try to save these last 3 because they get these get into lots of fun. So Pi Moroni, okay. So these guys are based in England. The Pi Hut's based in England, and Tendi, I believe, is based. I don't know if they're based here or not, but a lot of the gear that I get from them is US based. Pi Moroni, I love where their name comes. Pirate Monkeys, Robot Ninjas. But they build really cool. Like this is the Pico Explorer. So this is a Pico, right? And then you have this little bitty breadboard. And you have all the pinouts from here. They're all over here, right? That you can do. Plus, they have a little readout that is connected to the Pico, and you can have it produce a little, display here. Okay, and then on top of that, and I'll get to the other one. There's a Pico Bricks, which is a Kickstarter right now. On top of that, they have these little. Oh, they don't have the breakout. Where are they showing the breakouts? They have these, you can plug in breakouts into these little ports up here. I was hoping they would show us a picture. They're not showing us pictures of that. But they have extra little boards that have different functionality that you can plug into these little ports here that allow you to actually then expand that. So that would be like a good learning platform for the Pico. Right, so it's like what, $30 or so. Buy them in, buy a bunch of them, and then so that you save on shipping. I'm trying to find the Pico or the breakouts. Let me see if they do have it over here. Let's see the breakouts. They also have quick devices. So what we were talking about earlier, where you can plug in things with the quick connect. They have a lot of those kind of components, but like these guys have these really cool, they always have lots of cool LED things that you can build. This is the first thing that I broke, was one of these super nice LED boards. But, I'm trying to find the silly breakout boards. I don't see them. But Pico, they do a lot of cool stuff with those. Like here's a little, this is actually the RP 2040. That's the actual same connector. It gives you a USB connection, and you can wire it to your Pico. But I think exploring their website, right, you get these really cool, you got these little robot kits that got, they normally have, like, here's environmental hats, grow kits. Like this one is designed specifically that you put moisture sensors on them. It'll actually give you readouts. I've had a student use one of those. It worked out really well. Here's a weather hat. And it has, you can connect it to the sensors, and that then connects to the Raspberry Pi, right? So lots of cool stuff. Display hats, right? So this is a 2.0 display, so you can actually, put like a screen, right? A touch screen on your Raspberry Pi. I don't know, just tons of really good stuff. I have always been a fan of Pimoroni. They always have lots of really cool components. Here's the breakouts. Not the ones you can plug in though. I'm looking for the ones you can plug in. But they have a bunch of little things that you can plug in, and they get sensors and all kinds of other things. So they have their own kind of ecosystem with that. But I think there's lots of opportunities there with Pimoroni to do lots of really fun things. And I think I'm hoping that what you've seen so far is that you can see there's a ridiculous amount of things that you could actually do with the Raspberry. I don't know that we could have spent the same amount of time and find these kinds of devices and components that we could have done with a regular PC. Okay, so then Pi Hut's another one. They're also based in the UK, but they have a lot of really fun things. They do a lot of their own stuff as well. And so they've got these little micro machines. These are actually based on the microbit, but they also have ones that run with the Pico. I'm looking, they used to carry a bunch of robotic kits that we liked as well. LED strips, relays, fans, right? This is a feature-rich, production-grade, open source KVM over IP device. So it actually allows you to run KVM. Allows you to turn on and restart your computer, configure UEFI BIOS, reinstall OS, virtual CD-ROM flash. So lots of really cool things that you can do, right? And that turns your Raspberry Pi into a controller. And what we mean by hat, you can see right here, this is plugs in to the top of the Raspberry Pi. I don't think they have a picture of that, but it's actually plugged in. They do not. So just want you to be aware of that as well. So Pi Hut is another one. Let's go back to just the Raspberry Pi things. And we'll save this one as well. Paste that one. And then the last one, and this is not by any means exhaustive. These are just the ones that are kind of my go-tos. This last one is Tindy, right? So this is individuals who have gone out and built, and they build things for all kinds of devices. And I've used it to buy relay hats, right? But they've got all kinds of other, right? Mini Peppers, open source, Robot Dog. that looks like SCSI. Am I reading that right? So Pi sugars, batteries, right? So this is backup batteries for the Raspberry Pi. And just you can kind of see like people have made real specific things, right? So if you're looking to try to do something really unique or different, right? There's lots of options, right? And these are all kind of independent creators that have made these components. In fact, sometimes you actually buy the component and they build the component and then they send it to you. A UPS shield, right? So if you wanted the Raspberry Pi to be running all the time, you can do UPS. I bought a lot of relay boards, like something like this, and I've actually bought them from Sequence. So Sequence, this board, I don't have this particular board, but like if you wanted to run or do like a programming of your Christmas lights, right? You could run it. This is eight relays that allow me to actually control 8 sets of lights right off a single Raspberry Pi, which is a network-based computer, so I can send all the programming to it. I've actually had a student build that project and do a really good job controlling Christmas lights using relays. Okay, so I wanted you to be aware of these things because I really think that the more you explore them, the more you'll see like going back to that flexibility of the Raspberry Pi, what you can use it for. Because a lot of what we're going to do this week is going to kind of lean away from these extra gadgets and components and get me more towards the Raspberry Pi running as a, doing a CIS type of a task. But I wanted you to be aware of these things, that they exist and that they, I think the more you play with them or the more you explore them, the more ideas you're going to generate from that. The last hardware piece, I think, is this only has 3 days left. So we just came across this morning. Katie had sent me an email. I saw it separately, but then I saw the email. But this is Pico Brick. So this is and in fact, I think if you watch the video, like these all break apart. These all become independent components, right? So they ship it to you in this board, and then you break the board, and all of these little white components all become separate components, but they're all designed to make the Pico, kind of like that Pico breakout board that I was showing you from Pimeroni. There we go. So there's a kind of a graphic of it. All right, so you can break it apart. You can do all kinds of really fun things with the Pico. They're all using looks like the 4-wire connector kits. $79 for the base kit, it looks like. Actually, that's the highest. Is that the highest kit? Yeah, that's the biggest kit. So their biggest kit is $79. Looks like it's pretty much comes with everything there. Down to I think $39 was the lowest one. That's the Pico bricks, an ebook, connecting cables and battery. Again, obviously I haven't tried it because it's still in Kickstarter, but wanted you to be aware of it because it looks pretty cool. It could be a way to do all the Pico things in the classroom, right? Have them buy the kit, do all the different projects, and have fun with that. All right, paste that last one over. Okay, awesome. Does anybody at this point have hardware questions that I can attempt to answer? So, we talk about how I've done it. I've run mobile labs. You've seen me if you've been at any of the last in-person, the last couple of in-person winter conferences. I've brought the lab there. So, and with those new Pi Top 4s, my lab is a lot more condensed. In fact, I think I can, instead of having 3 big Pelicans, I can get away with 1 Pelican for a 24-person classroom. So that's the other thing that's kind of neat about the Raspberry Pi is that the compact size. I can get it down into small space. I've actually seen somebody have a 10 computer lab that they put in a suitcase, right? So they took it as a carry-on. I see Richard showed up.
Yeah, hi, Carrie. I don't have any questions about hardware. That's pretty
worries.
amazing, though. And what a tremendous resource you are. You've really studied this quite a bit. And those of you that were lucky enough to get into this workshop, you know, we had a limit and we have a pretty extensive wait list. So, Carrie, there's a lot of people that are knocking at the door trying to get in. Anyway, I wanted to welcome everybody. I popped in. You guys were on a break, I think, earlier, and just wanted to welcome everybody to our 7th annual faculty development weeks. We're hoping someday. I see Rick is here, and I thought I saw, who else was here? Marcelo is here too from Cabrillo. We're hoping someday, Rick and Marcelo, to get back to Cabrillo and do these things face to face again. But I know right now this is anyway, welcome everybody. Don't forget to check in the platform occasionally. Take a look at the tavern, and there's hidden kind of things to do and prizes to be won. Who knows? You might win one of those detachable break apart PI things that you just showed us. That looks like a pretty cool raffle gift right there.
One of these days, we're gonna have to do that. Definitely.
All right. Well, welcome everybody. I don't want to take up any more of your time, and enjoy the week. And if you have any questions, don't hesitate to email me. And have a great week.
All right. Thank you,
Thanks,
sir.
Carrie.
My pleasure. All right. Cool. All right. So it looks like I'm just gonna look through the chat real quick. Chicago Electronics has an educational discount for educators. Easy to work with. Okay, so I have never used them before. I was trying to gather up as many because I know it's really hard to find gear. So so there's a good review there for Chicago. One of my hopes is eventually to we have a photovoltaic program at CNM, so I really want to get with them and have them build me a mobile solar powered battery setup so that we can actually take our lab, say, to a park, right? Or out to the, a reservation. We have probably 24 reservations here in the state where we can go where power is a problem, right? And actually do outreach, right? And what's cool about that is because the Raspberry Pi is so small and uses such a small amount of power, right? You run it with a 5-watt power supply. It's got the, I think the newer ones draw like 3 amps or so. But so we can get, we can run an entire lab off of a battery bank that fits in one of those portable, like a cooler, right, kind of a thing. So that's kind of one of those, kind of things that you can, think about doing as a project, right? Solar powered. But anyways, it doesn't look like there's anybody who has any questions. I think I kind of drowned you out with questions. Or drowned you out with like so much stuff on where you could buy things, suppliers, things like that.
Can you add a second network interface card to the Pi? Like a wired one?
We do a lot. Well, yeah, you can. It's I use a USB Ethernet adapter.
Okay.
So you have we already have wireless, right? So you have a Wi-Fi, which is and we didn't really talk about the specs of these things, right? I don't know if you guys if that's of importance to you, but it should be. So because we're computer people. So the technical specs on this thing, right? So it's a Broadcom, it's quad core, 64-bit, right? It's running at 1.5. So essentially, right, same kind of processing power you're going to find in modern day cell phone. Okay. The Raspberry Pi 4 comes with 1 gig, 1, 2, 4, or 8 gigs, right? You buy it by that version. So the 2 gig version costs $35 on a normal day. The 4 gig version costs $55 on a normal day, and the 8 gig version costs $75 on a normal day. In my classes, I have shied away from the 8 gigs because there's some firmware EEPROM things that cause problems with existing labs that we use. So I've had them avoid those. However, lately, we haven't really had those kind of issues. So I think maybe they fixed that, maybe they haven't, I don't know. But you get it in one of those flavors, right? And then it comes with 802.11 AC, Bluetooth 5, and low energy, it's low energy Bluetooth with gigabit Ethernet. So so you're running at the current, wireless runs at the current top speeds that you can get. Obviously, we don't have multiple antennas. Bluetooth is nice, and we use in the security class, we actually connect with Bluetooth. And then gigabit Ethernet. So before the Pi 4, your gigabit was tied to the USB, and then that was limiting your gigabit Ethernet port to 300 megabits, right? So, oh, nice. So we'll get you hooked on Humble Bundle here shortly. Thanks, Mike. So you have really good wireless, right? You have really good Ethernet. And so you can run both of those at the same time on 2 different networks, right? So you can actually set your Raspberry Pi up as an access point. You can set it up as a router. You can set it up as a VPN concentrator. There's lots of things that you can do with it. We can take USB. There's 2 USB 3.0 ports, 2 USB 2.0 ports. So you can plug in an Ethernet, USB Ethernet adapter, or a USB wireless adapter if you wanted to be kind of on a two wireless network deal. Or if you wanted to do wireless like pen testing, you can buy a USB wireless adapter that it's got to be able to go into promiscuous mode. So there's some, I can't remember the exact requirement, but there's a requirement in order to put that device into promiscuous mode for scanning of the network. So that's how you would do the wireless scanning. Is you would use an external USB connected wireless access point. So you can do multiple Ethernets, multiple wireless, whatever the case may be. Okay. The Pi 4 also has the 40 Gpio pins. We already talked about that. It's got 2 micro HDMIs, right? And both of those support 4K. So think about that. Like, this is a $35 computer that has wireless AC, gigabit Ethernet, and can support 2 4K monitors for $35. We're not talking about anything else on this thing, but just those things for $35. I guess it's a pretty powerful device. Okay, it's got the 4-pole stereo, so it's got the 3.5 millimeter stereo if you need to. Your operating system is going to load on a micro SD card, and it runs off of a 5-volt, 3-amp power supply. Okay, we can run PoE on it as well. So pretty cool stuff. And then they do mention down here, right? A quality 2.5 can supply enough, right? Can supply enough, but the 3.0 is a little better. So as I was rebuilding my kit last week, I started getting rid of all of the 2.3s and the 2.1s and the 2s, the 2-amp power supplies, right? So it's a pretty beefy computer for the price that you're paying, right? So if you're paying $75 for that 8 gigabyte version, right? So you're basically paying for $40 for 4 extra gigs, right? $10 a gig. Okay, from a spec standpoint. Awesome. We got about 2 minutes before the next break. So while we're waiting, let's give you one other resource that, again, it's like a drug pusher. Because everything I'm going to show you is money that you're going to want to go, oh. So if you're not familiar with Humble Bundle, right, Humble Bundle was kind of made their name with game, selling game bundles. However, I'm a really big fan of their book bundles. And the one that Mike just pointed out is they just came out with this big data and IoT. So I haven't even seen it yet. So, but for $18, you're going to get 20 ebooks, right? You can download them in PDF format. I think .mobi and some other formats, but right? So this is the list of things that they have on this particular bundle. They're starting to get into some different, yeah, all right. Right, so, and again, I'm a big fan of having resources available. So when there's a bundle that related to courses that I teach, I usually grab it so then I can resource it to be better for myself, or if I'm teaching the class at the time, then I'll have my students possibly pick it up. There's a cybersecurity bundle. So if you're in cybersecurity, there's a bundle here, $18 gets 24 books. Ridiculous amounts of goodness. Okay. And then I know for those of you that teach sysadmin, oh wait, I think it shows up as a software bundle. Or maybe not. Yeah, nope, that's not it. Where'd it go? Oh, maybe it's gone. No, it's right here. We have a couple days left, 2 days left. So Pluralsight AWS training. So $25, 20 items. And it's all online Pluralsight training for AWS. I have this bookmarked. I have, I've signed up and I can, I get the emails and things like that. So I just haven't seen it because I don't have my email on right now. But I kind of keep an eye on this because there's always something interesting related to the course, or the courses that I teach that comes out, and they'll put out a book bundle once every week or so. And sometimes I don't really need that bundle. I just kind of ignore it. And then, other times I'll see a bundle and I'll know right away I want to get it. And then sometimes I'm like, I'll wait. And then either, depending on where I'm at, maybe get it or not get it. But Humble Bundle is, I just think it's a really good resource to get, perfect time, to get, some content that you can either use in class or teach, use it to teach yourself, or stay up on topics. So I'll throw that in our list as well. And let's take like a 5-minute break at this point. I do want to get a couple more things done before lunchtime. And we're gonna take lunch in like 35 minutes. And then we'll come back and we will start working. We'll get onto the Raspberry Pi at that point, okay? So let's do 5-minute time. And yes, I will record over the break. All right. Cool. Got about 30 minutes before lunch. Earlier today, I added, I created and added everybody to, oops. I gotta log in. To 3 Cisco courses. They're the instructor courses for the IoT, and I didn't add the content that I normally added. I just created the courses so you can see the courses that are provided by Cisco. Okay. The caveat there is that I believe these courses end of life next September, next year sometime. So I think, and what they're using as replacements, we're not sure. I haven't heard anything lately, so I don't know 100% what's going on there. I thought I just logged in. But again, it's more resources to go look through, and I'm going to put that, we'll cover that in the morning. We'll cover the classes in the morning, so you see the resources that Cisco is going to provide. From a curriculum standpoint, from a lab standpoint, but I just wanted you to be aware of that, so that there are 3 classes, actually 4 classes right there. There's the connecting things, and they all start with this 2022 WOTC. IoT security, IoT big data, and then IoT fundamentals hackathon. Okay, so those are the 4 IoT fundamentals battery that Cisco created a couple years ago. And I believe, I want to say end of life is a year out from now, like a little bit, like we have until next September. But I want you to see the courses. And there's some labs in there that actually we may try to pull off this week. And then there's this the hackathon playbook, which I think is a really good format if you wanted to do a hackathon or even use some of the baseline kind of brainstorming tools with your students. So we'll kind of look at those just again, for you to have resources available to you. If you are a Cisco instructor, right, on the Cisco Academy, you should be able to create these courses on your own without you. They no longer require you to have been certified to teach them. Okay, these 4 classes. Okay, I'm trying to think if there's anything else. So I just want you to be aware that you were added. That's why if you go out there and you see all this extra stuff, that's why. If you know, after the workshop you want to remove to clean up your stuff, just let me know and I'll take you off. But I think I left them open until September, so you can go and play with them, take a look at them, and go from there. But I will talk about them tomorrow. I just want you to be aware that they exist. The other thing that we'll talk about tomorrow is the Cisco has this new, what is it called? Skills for All or something like that. Yeah, Skills for All. And in the Skills for All courses, there's a lot of self-registered courses that you can take, right? So cybersecurity, basic networking. One of those is the new IoT, Introduction to IoT course. So this is this used to be like a 20-hour course, it's now a 6-hour course. That makes a lot more sense. Just kind of introducing IoT. So it's pretty cool. And again, it goes kind of in line with the Raspberry Pi. But you can see there's lots of really fun courses. If you're not aware of this stuff, I mean, we have network essentials for 70 hours worth of work that you can log into. So there's a lot of cool stuff out there, right? And the skills for learning. Again, that's another one that we will, or skills for all, that we will kind of look at where that may fit as far as Raspberry Pi is concerned tomorrow. Okay, but that one I didn't sign you up for. It's part of the Cisco curriculum material stuff. Excellent. All right, so let's try. I don't know if everybody can get to the Miro. Got a couple things. So one of my first thoughts was, we've done kind of talked about the Raspberry Pi and all kinds of things and all the parts and pieces and stuff like that all morning, right? And the goal of this class is to kind of, how can we put the Raspberry Pi into, to using it to teach CIS topics. So I started a mind map. I don't know if you guys are familiar with mind maps. But right, so CIS topics, we got programming, Internet of Things, computer science, industrial uses, networking. Right? And the idea was for us to spend a couple, hello, Sarah, to spend a couple of minutes brainstorming, right? So for example, like networking, right? So if you click on there's a little button, little plus button next to it, I can type in wireless access point. Okay. So my hope is especially because there are folks in here that that teach programming, or possibly some of these topics in computer science or like web development, maybe even cybersecurity, things that I am aware of, and I do teach some things in those, but not courses. And kind of think through, maybe look at some of the resources like on my webpage or things like that, but maybe look for some examples of things that we could use the Raspberry Pi to teach with, right? And then just add things, right? And if you want to add another topic, we're not stuck to this. This is a brainstorming session, right? So I'd like to spend like 10 minutes, right? And have you as a group populate all of these, with all of these topics with potential ideas, right? Of things that we could maybe use the Raspberry Pi for. And even if you're not sure, right? That's part of this whole process. Like, is this think through something, can I teach in sysadmin? Can I teach cloud computing? Right? I don't know, maybe. Right? Could I teach, well, I know we can teach Kubernetes, but right? Could I teach Kubernetes? Could I teach, I don't know, could we do network infrastructure, right? So, and what I mean by network infrastructure is like, could we do, could we do DNS, DHCP, etc.? Could we do those kind of things? Right? So maybe we don't know. Maybe it's something that we're interested in trying to figure out. Could we do it? Right? But that's kind of the thinking here. Is like, especially if you, if you have a topic that you normally teach, like think of things that possibly we could use a Raspberry Pi for, or maybe just the topics that you would teach in that section, right? So maybe not even think, can we do it with a Raspberry Pi? But maybe just think, what kind of things do I teach in these areas? And then we can then extend that out, like on cloud computing, we could extend it out later on throughout the week with, here's the things that we can use the Raspberry Pi to do that with. Does that make sense? All right, so I'm gonna do that. Hopefully you guys are still there. There's 13 of you here, so let's do a 10-minute timer, right? And you just log in and you should be able to click, plus and whatever, and just add things, right, on the board. There was music. I could have picked music. It's also one of those things like, I don't even know how to use this tool. And you were given, Heidi, you were given a link, right? I'm gonna post a link. I just posted a link to our board in the chat. Hopefully that gets you there. Trying to figure out how these, part of this is learning this tool, I think. So this may or may not work well for us. It may not. See. So I know on mine, like if I have my cursor over the cybersecurity, a little plus symbol shows up. And if I click the plus, it will give me a box to type in. You can right click and hold, and you can move the, to move the whole screen around so you can get it if you're not seeing something. And if you scroll, you can make it bigger or smaller. So Heidi, just click somewhere on the screen. I think that lets go of the big selection. Anywhere but in the box. Okay, awesome. So part of this is learning how the interface works. But I think what's neat about this is that this is something we can then spend the rest of the week, improving. And then as we find resources, like for example, I'll use the wireless access point up here in the right top left, is we can then tie a web page to each of these items. So throughout the week, if you think of something, right, come back to Miro. We don't have to do it. It's available all week long, and just add stuff in as you think of things. I wanted to do this as a group so that we can kind of see how it works. And the hope here is kind of fill out the topics and then, out at least 2 levels. And then once we have the levels, then we can start to attach projects, web pages, resources, things like that, links to each of those different items, so that when you're done, you have this, massive mind map, created by everybody, with resources that can be utilized, immediately, in order to teach whatever topic it is that we've got listed in there. All right. So that's the first thing. The second piece, I'm going to jump over. So I'm going to click on the Miro up in the top left there. Created this is a template that they had automatically created for us. They have a bunch of templates out there, and I thought this would be nice. So as things came up, right, items under discussion, look for opportunities. So what kind of things we can use. But I did is I just stuck a bunch of sticky notes out here. So if you grab a sticky note and you double click on the sticky note, then you can do like Cisco Unedited courses, right? Because that's something that we're going to talk about tomorrow, right? So the idea of that is then I can then take that card and we just drop it on, right? I'm going to drop it on and keep it on the radar. So if you have an idea or a thought, you can just grab a card and type in whatever it is you're thinking, right? And then just throw it up here on the items under discussion. And then as the day goes or as the week goes, I can reevaluate those and move things around and try to make sure that I include the topics that you're interested in, right? So if and that's what I want this kind of be like, what kind of things would you like to see? Like sort of, I know from the survey that I did the other day, a web, it's like more like I guess web programming example. I think let's go with that. It's a little bit small, but you can make it a little bit bigger. Right. So, and if that's not right, but that's kind of the thinking, like, if there's things that you want to see or questions that you have, right, you can come to this parking lot and you can grab a sticky note. I just grab a sticky note and I just a right mouse or a left mouse click to drag it and then double click on it to type into it. And then you can adjust the size and then drag it onto the items under discussion board, or use one of these notes so we have them there. And you can do that at any time. And the idea of that is that if something comes to mind, jump over there to Miro, type it in a box, throw it on there, just in case, so I don't miss it. Because then I'll review these after class, and I'll just make sure that I've, as I formulate the items that I want to cover tomorrow, right, we can either include those or make sure that we get them kind of fitted somewhere where they're appropriate throughout the week, or answer them directly if we're not going to have time in the general class. That makes sense. Okay.
How did you get to that board?
So I just clicked on the Miro up in the left corner there, go to boards. And then there's 2 boards. I see 2 boards out here. I don't know if you guys see these or not. Mind map is there, and then the parking lot is here.
Thanks.
So I've got, and see, it looks like everybody's here. Wonder why. I thought I saw Sarah's on this one, right? So somebody's on there. Okay, you guys can get there. Good. All right. So those are the two boards. If there's other things that we need to add, there's all kinds of really cool things, of brainstorming and just all kinds of fun stuff that you can do. And just at this point, those are the two that kind of made most sense to me. I think, the parking lot will be used to capture kind of the to-do list or things of interest. And then the mind map is for us to kind of build out like a set of resources based on CIS topics, like bigger topics, say networking. Then we can break that down into smaller pieces, and then we can attach resources to those smaller items so that you have, if you wanted to do a DNS server, then here's a couple of web pages that will show you how to do that, right? And then that becomes, the groundwork for you to build a lesson around that going forward. All right. I don't think I've missed anything else. In the chat. I will turn off the recording over the lunch break and put a big record sticker on the monitor so I don't forget it. But we're at that time now, so 12:57, so we're kind of right at the right time. So what we're going to do is we're going to take break for lunch, right? So we'll be back in an hour. So it's 1 o'clock my time, I think 12 noon on California time. So we'll be back at 1 California time. And from there, I want to get rolling on the process to install an operating system on the Raspberry Pi. And then we'll get some Raspberry Pis set up this afternoon so that we are ready to roll tomorrow with labs. All right. All right, record stickers on there. I'm going to go ahead and stop my share right now. And we're going to